is Dr. Holt. This one is on a cantilevered beam. I'm going to do the summation of forces. I want to find out what the reaction is going to be at A. I also want to find out what the tension is going to be in CB. In this beam, it has a mass of 5 kilograms, so it's going to have a load coming down of 49 newtons, which is 5 times 9.8. At the end, it also has an 80 Newton force being applied at an angle of 70 degrees coming off the horizontal. Now, I've already kind of started this to save a little bit of time, but again, I'll go through the steps carefully. The first thing you want to do is draw yourself a good free body diagram. Again, that's essential. Do not, and let me repeat that, do not try these problems without a good free body diagram. It's just going to be frustrating for you. So what I did is I drew this free body diagram here, and I assumed that FAY is going up. I may be wrong, but I'm making an assumption right now. It makes no difference. I assumed FAX is going to the right. Immediately broke each one of these into components. 80 times the cosine of 70 gave me the 27.362. I took 80 times the sine of 70, and that gave me a value of 75.18. I showed here, since this is pulling back up like this as a vector, I broke it into two components. I broke it into an FBY here and an FBX here, and I recommend that. Alright, and then at the middle I had the mass times 9.8 coming down, and that's 49 newtons, and then again I drew FAY and FAX, just in my, again, making the best guess, and I may be wrong. From that, I go right to my equations. I know the summation of moments around A have to equal 0. I know the summation of forces in the x direction, or horizontal direction, have to equal 0. I know the summation of forces in the y, or vertical direction, have to equal 0. I go ahead and from that write my equation of my moment. I take the 49, I multiply it by the distance from here to here, which is 2.5. I make it negative because it's rotating clockwise, trying to rotate the beam clockwise about A. I do the same thing here. 75.18, I multiply it by the distance of the beam, which is 5. It's also trying to make it rotate clockwise. I make it negative. The only other thing, other force causing a moment is FBY, FBX, FAX, and this force cannot cause moments only because there's no vertical distance away from A. So this vertical distance would be 0. So that's my first equation. I can go right now if I want to and solve for FBY. However, I went in and wrote the other two equations. The summation of forces in Y. I'd have this value here minus this value here plus this value here minus this value here equals 0. I cannot solve this equation because I have two unknowns. I sum the forces in the x. I will have FAX minus FBX minus 27.362. Again, two unknowns. So what I did there from that point was I took this first equation here. I took everything, I moved it to the right side and divided by 3.25. That gave me FBY. That's 153.353 newtons. All I have to do now is take that value here, if I choose, or put it back into here. I can solve for FAY. However, before we do that, let's find out what the rest of the forces are at FB. Or at B. I'm going to draw my vector here. This represents the vector coming from B to C. Now it's going to have two components. It's going to have, like I said, the FBX and FBY, but we know FBY. So I will draw the components here and here. We know this value right here is 153.353 newtons. All I need to do is find theta, and then I can find FBX. I go back to the picture. This is my theta. We know the tangent of theta is 1.5 over 3.25. So I can write the tangent of theta is equal to 1.5 divided by 3.25. We take the inverse tangent of this value right here. That will give me theta. And when I do that, I will find out that theta is equal to 24.775 degrees. Since I know that, can I not say that the tangent of 24 0.775 degrees must equal to 153.353 newtons divided by FBX. All I have to do here is solve for FBX. When I do, FBX will give me a value of 332.265 newtons. Now at this point, I can find out what FB would be. All I gotta do is do Pythagorean theorem between here and here, because I'm doing these two components. This one squared plus this one squared. Take the square root of that, and that'll give me FB here. If I do that, excuse me, FB will give me a value of 365.946 newtons. Alright, so now we have FB pretty well defined. All I have to do now is take this value, we'll put it back into this equation, and we'll solve for this one. And I'm going to try to grab that so I don't have to write it all over again. We'll see if I'm successful. Edit, copy. I'm going to scroll down here, edit, paste. And I was successful. I will take out FBY here. If I can get that. When I take this out, I will put back in the FBY value. And the FBY value was 153.353. Okay, so we will just solve for FAY, move everything to the other side, and you will find that FAY is equal to 29.173. However, do you notice here that when you move this other side, you get a negative here? What that negative means, it means actually that I have this going the wrong way. So all I have to do is take this and I flip it, and it should be going back this way. If you get confused by this, a good thing I would recommend here would be to go ahead and show the vector coming down, and then go ahead and eliminate the negative. And same way here, it's good to go ahead and have the direction here. Like I have FBX, I should show the arrow going back this way. FB, I have the arrow going back up this way. And this one here, I would have it going back up. Again, it's good to show the vectors as you go along. Now, since I know FAY, let's go back here. I'm okay there. Let's go back to this equation. I know FBX, we'll put it back into here, and I'll solve for FAX. So when you take the value that you had for FBX, and FBX was 332.265, I'm showing a negative, so it's okay just to put it right in. When I solve for that, I will get FAX is equal to 359.63 newtons. Again, it's positive, so it's going back that direction as I have shown. So those are the values for FAY here, and those are the values for FAX there. Again, the problem is not that difficult. It's more, excuse me, that you've determined a methodical approach and just follow it straight through. The free body diagram, again, this right here is essential. If you can draw that, the problem will just literally fall apart as long as you follow this sequence: the summation of the moments, the summation of forces. Excuse me. So anyway, this is Dr. Holt. I hope this video was useful in how to solve a cantilever beam problem with more than one load, especially with one load coming in an angle. All right, best of luck.